Hello, welcome to my channel. In this video, we'll be using logarithm table to perform calculations. We'll start by discussing how you use logarithm table to find logarithm of a number. Okay, let's do these examples that was given. They say find the logarithms of figure 900. Let's start with 900. For figure 900, what you should know is that when you want to find logarithm of a number, the first thing to do is to express it in a standard form. And what is standard form? Standard form is expressing a number in the form of a times 10 raised to power x, where a is equals to number 1 to 10, and x can be either a positive or negative integer. Okay, so if you want to express 900 in standard form, it will be equals to 9.00 times 10 raised to power 2. How did we get 9.00? We took points from here. You know, this number is the same thing as 900.0. So there is a point here. We take it here, 1, 2. And it is from this that we get these 2. And the points come here. Having expressed the number in standard form, the next thing to do is to find the logarithm of the number by checking it in the logarithms table. The way we check in the logarithm table is, if you look at the logarithm table, we have columns and we have rows. Okay, now you go to the first column where they write x here. You look at the first two numbers in the standard form that you express, which is 90. This is 90. So you go to 90. The 90 is here. This is up to 54. Then it continue here, 55 up to 99. So the 90 is here. Okay, you come to this row. Then you go to column 0, the following number, and if you look at it, this is column 0. So the logarithm is this. That's 95.42. Now, how do you express the logarithm? You express the logarithm as 10 raised to power 0.9542 times 10 raised to power 2. Okay, so from the rules of indices, this will be equals to 10 raised to power 0.9542 plus 2, and this will be equals to 10 raised to power 2.9542. So log 900 will be equals to 2.9542. This is the logarithm of 900. Let's go to the second question, which is 0.0015. The first thing we do is to express 0.0015 in standard form. And that will be equals to 1.5. How did we get this? We carry this point from here. 1, 2, 3. Okay? That will be times 10 raised to power minus 3. The reason why it is minus is because we are carrying these points towards the right. Okay? So that's why it's minus. If we are carrying it towards this direction, it will be plus. Having gotten the standard form of the number, the next thing to do is to look at the this is to look at it in the figure four figure table. Then how do we look at it? We look at this number here, number 15. Okay, let's go to the x column and let's look at this is 15. Okay, since there is no number that follow here, we assume it is 0. Okay, number this column, this is number 15 colon 0 1761. Okay, so this will be equals to 10 raised to power 0.1761 times 10 raised to power minus 3. Okay, and this will be equals to 10 raised to power 0.1761 times minus 3. Now, when you want to evaluate this, it is not just like the common mathematical operation that we do, where you say this one will be equals to 0 points, let's say 2.8 something something. No, it is not done like that. What you do is this: for every logarithm number, there is characteristics and the mantissa. Okay, logarithm numbers are usually expressed as number dot some other numbers. Okay, the number on the left side is called, they are called characteristics. Okay, and the number after the points are called mantissa. Okay, what you do in logarithm when you are adding it together is that you add characteristics separately and mantissa separately. And if you look at this one now, the characteristics is 0 and minus 3. So if you say 0 minus 3, that will be minus 3. But in logarithm, we don't usually write minus logarithm. What we write is bar 3. Okay, point. So these are our characteristics now. Okay, these are our characteristics. Then it will be followed by the mantissa. This is the mantissa here. Okay, and this one has 0 mantissa. So therefore, if you are to add it together, because of, sorry, this should be addition, not multiplication again, since from the rule of indices. If you are to add it together now, it will be 1761 plus 000, right? So that will be 1761. So log 0.0015 is therefore equals to bar 3.1761. So this is how you'll be checking the logarithm of numbers. Recap. The first is to express the number in standard form, and after you express it in standard form, you check the value, you check the logarithm of the number from the four figure table. Now, having known how to check the logarithm of numbers using the four figure table, the next thing we'll do is to use the knowledge that we have to do mathematical evaluations. We are going to check the logarithms of each of these numbers. Where the numbers are multiplying, we are going to add the logarithms. And when the numbers are dividing, we are going to subtract the logarithm. Okay? For clarity or visibility, we are going to create a table. And this side will be the number. And this one will be the logarithm operations. Let's start with 818.3. What is the logarithm of 818.3? Using the knowledge that we got in the previous slide, let's look at the logarithm. 818.3. If we are to express it in standard form, we'll be counting this, take these points 1, 2, meaning that the logarithm of this number will be 2 points something. Now, what is that thing? 2 points something. This 2 is the characteristics. Now, what will be the mantissa of the logarithm of this number? We are going to we'll go to four-figure table and check the column 81, x equals to 81, and this is x, and this is 81, right? Under column 8, column 8 is here. So we trace it up to this place. This 9128, okay? Then we have one last digit, which is 3. The way to use this 3 is to come to the difference here, and this is 3 here, okay? We trace this 3 to the same row where we found the previous values, okay? So what we do now is that under x is equals to 81, column 8 here, difference 3. This section is the difference. Difference 3 is 2. So what you do is you are going to add this to this number. Okay, so that will be this 9128. When you add 2 to it, it will become 9130. So you write 9130 here. Okay, so we have been able to get the logarithm of this number. Okay, next we are going to do is to get the logarithm of this number, which is 72.5. I'll have to do this one pretty fast. That is x equals to 72, okay, column 5. This is column 5, which is 8603, right? 8603. And don't forget that this point is going to move once like this. So the characteristics of the logarithm will be 1 point. The characteristics of the logarithm will be 1 point. Then we are going to get our value here. What is the value here? 8603, right? Our value here, which is under the column 5. 1.8603. Okay, now what are we going to do with this logarithm? We know that they are multiplying each other. This number and this number are multiplying each other. What we are going to do here is to add the logarithm. And for us, when we add the logarithm, this will be 337. This will be 17, right? Which is 7 points. This is 3, and that will be 4. The logarithm of 2.905 will be, let's first of all try to get the characteristics of the logarithm of this number. The characteristics of this logarithm will be 0 point. The reason why it's 0 is that if you are to express this in standard form, that will be times 10 raised to power 0. And if you recall, when you transform a number into a standard form, this will be the characteristics of that number. So The characteristics of the logarithm of this number is 0 point. The next thing is to look out for logarithm in the logarithm table, which is x column of 29 under column 0 with difference 5. This is 29, right, under 0 with difference of 5, and this is the difference of 5. Okay, this is 4621. 4621 plus 7, that will be 4624 plus 7, that will be 4631. So that will be 4631. Okay, now since this number is dividing the remaining numbers, and we have found the logarithm of the numbers that are the numerator, we are going to subtract this one from this one. So since it is dividing, according to the law of logarithms, we are going to subtract the logarithms of those numbers from each other. So if we subtract this, this will be 3 minus 1, 2. This will be 0, 1, 3.4. Now we've gotten the logarithm of the all these numbers, and we have performed operation using the law of logarithm, which is adding when the numbers are multiplying and subtracting when the numbers are dividing. Now, for us to get the number, the final answer, we have to convert this into number by finding the anti-logarithm of the number. So the anti-logarithm of this number is, let me show you how we are going to find it. To find the anti-logarithm of this number, we are going to use the anti-logarithm table, which I will show here. This is the anti-logarithm table. For us to find the anti-logarithm, first of all, we are going to use the mantissa of the logarithm. We leave the characteristics alone for now. We are going to use the mantissa and go and use it to search the value in the anti-logarithm table. So let's take note of the mantissa 3102. We'll now go to the anti-logarithm table. This is the anti-logarithm table, and we know our mantissa is 0.3102. What we are going to do is 0.3102. We'll go to where x is equals to 0.31 under column 0, difference 2. Okay, so this is 0.31 under 0, which is 2042. Okay, 2042 difference 2. This is difference 2, which is 1. Okay, so 2042 plus 1. 2042 plus 1, which is the difference, and this will give us 2043. Okay, now let's go back to, so what we got is 2043. Having gotten the value from the antilogarithm, we are now going to use the characteristics, and the characteristics is 4. What this characteristics means simply means is that this will be times 10 raised to power 4, and our points, the starting point of the starting position of our point will be here. Okay, so our final answer is 2.043 times 10 raised to power 4. Okay, this is the final answer. Let's look at another example. They say evaluate using table. Let's start with question number 1. 82.5 squared. How are we going to do it? Let's draw our table. Let's say this is the number and this is the logarithm. The first that we want to deal with, number 1, is 82.5, right? Let's first of all find the logarithm of 82.5. That will be, first of all, expressing it in standard form. We'll carry this point once up to this place. That will be 1 point. Then we'll go to the logarithm table and look at 82 under column 5. So this is 82 under column 5, which is 9165. 9165. Now, since this is squared, and in logarithm, when you have log a into base 10 squared, this will be equals to 2 times log a, meaning that we are going to multiply our logarithm by 2. Okay, that is why we will now multiply this one by 2. Let's see what we get. This will be 0, this is 12, 13, 3 remainder 1, this is 2, 3, 18, 8 remainder 1.23. Okay, so 2 times this logarithm give us this. Now we have this our final logarithm. The next thing to do to get the number is to find the anti-logarithm. And for us to find the anti-logarithm, we'll first of all concentrate on the mantissa. We'll go to anti-logarithm table and look at number 83 under column 3, difference 0. Let's do it. 83, 30. This is 0.83 under column 3. That is 68.08. Okay, difference 0, which is 0. Okay, 6808. So let's go back. This will be 6808. Okay, and now having used mantissa to get the number from the anti-logarithm table, the next thing is to use the characteristics, which is 3. And don't forget that to use our characteristics, we just say times 10 raised to power 3. Okay, and the starting point for our point will always be here, which is just one figure to the left of the point. Okay, so our final answer is 6.808 times 10 raised to power 3, which is the same thing as 6812308. This is the final answer. Okay, is 2.5 squares. Let's look at question number 2, which is to find the cube root of 1630, okay, 1630. First of all, let's find the logarithm of 1630. To find the logarithm of 1630, we make a standard form, and that will be by carrying the point from here, 1, 2, 3. So we know the logarithm will be 3 points. We've gotten the characteristics. The next thing is to look for the mantissa. We look at 16 under column 3 difference 0. That will be 16, 3, 21 to 2 colon 0, which is 0. So this will be 21 to 2. Okay. Now, having gotten this, what will be the relationship here with the logarithm? Since it is cube root, what we are going to do is divide by 3. Why are we dividing by 3? You know, this is the same thing as if you say in rule of logarithm, log a raised to power 1 over 3 is the same thing as this, right? Okay, so you can evaluate it as 1 over 3 times log a, and this will be log a divided by 3. So we are dividing log of this by 3 now. So let's do it. If we divide it by 3, that will be 1.64606. Okay, so that will be equals to 1.07073. Having performed all the operations necessary in the logarithm form, the next thing is to find the anti-logarithm of this number. And to find the anti-log of this number, we'll first of all look at the mantissa, right? So we'll go to the anti-logarithm table and look at 0.07 under 0 difference 7. 0.07 under 0, which is 1175. Okay, difference 7, which is 2 plus 2, and this will be equals to 1177. Okay, 1177. Now to use this, which is the characteristics, that will be times 10 raised to power 1. Okay, and we put our points just at the starting points where there is only one number before the point. Okay, so our final answer is 1.177 times 10 raised to power 1, which can be also be expressed as 1177, and that's our final answer. If you enjoyed this video, kindly like, subscribe, and share. And don't forget, after subscribing, click the alert bell sign for you to be notified when I upload new videos. Till I see you in my next video, thank you for watching. Bye bye.